What is a multispectral lens? A multispectral lens is a camera lens that can simultaneously sense the image of the object being photographed in multiple wavelength ranges. Its image is composed of spectral values in multiple wavelength ranges. The spectrum on each band has different capabilities to transmit specific physical information, such as the reflectance and radiance of vegetation, water, land, clouds, and other targets. Since multispectral lenses have high band resolution and spatial resolution, they can well identify and analyze the different characteristics and changing trends of the objects being photographed. They are often used in agriculture, forestry, environmental monitoring, geological exploration, and other fields for identification, classification, measurement, detection and inspection, and other application scenarios. Application areas of multispectral lenses. Multispectral lenses have a wide range of applications, including, but not limited to, agriculture, ecology, forestry, meteorology, environmental monitoring, urban planning, geological exploration, etc. Among them, they are most widely used in the agricultural field and are of great significance in crop monitoring, fertilizer management, and early warning of pests and diseases. One agriculture field. Multispectral lens has a wide range of applications in agriculture. Multispectral images can be used to receive photosynthetic metabolic information of crop growth and key information of flowering and fruiting of vegetation, and can quantify fine information that ordinary photos cannot present. Farmers can use it to infer the growth and health of plants, so as to carry out effective irrigation management, fertilization and pest control, and optimize agricultural production systems. At the same time, the collected multispectral data can also be used for mapping, land use and land cover assessment, etc., to provide decision support for farmers. 2. Forestry field. In the field of forestry, multispectral lens is mainly used for research on forest types, forest health status, and species composition. Through reasonable spectral image processing, it is possible to classify and analyze different tree species in geographical landscapes in forests, and to monitor and warn of factors such as forest fires, diseases, and insect pests that may cause tree shrinkage and death. The application of multispectral has a high spatial temporal resolution compared with other Earth observation platforms, and has shown more stable performance in tracking forest cover changes, measuring forest growth and forest product volume. 3. Meteorological field. In the field of meteorology, meteorologists generally use multispectral images to predict changes in climate patterns in nearby areas. Multispectral data can be used to smoothly detect gases, particles, ocean flows, wind fields, and other aspects. In particular, when analyzing the properties of clouds and various frontal forms and edge transitions in other weather systems, cloud images with ultra-high temporal and spatial resolution can be quickly obtained and help develop weather forecast algorithms. 4. Environmental monitoring field. Multispectral lenses are also widely used in the field of environmental protection. For example, monitoring the physical, chemical, and biological life cycle processes in seawater. Using multispectral images can derive the physical or chemical parameter values corresponding to different radiation levels, and then understand the number of species and diversity levels in the marine ecosystem. For example, by scanning water sources such as rivers, lakes, reservoirs, etc., to detect the quality and pollution level of water bodies. It is convenient for governments or organizations to formulate corresponding management plans. For example, using multispectral technology to monitor air pollution in cities can timely assess the degree of air pollution and formulate effective control strategies. In addition, using multispectral technology for garbage classification monitoring and processing can achieve efficient classification and recycling of garbage. 5. Geological exploration field. Multispectral lens is also widely used in geological exploration. For example, for geological structure analysis, multispectral lens can obtain high-resolution images of surface cover. These images can be used to analyze the characteristics and distribution of different geological structures, understand the connection and evolution process between different geological structures, and provide reference for the exploration and development of resources such as oil and natural gas. For example, in the exploration of mineral resources, in the exploration of copper, gold, and other deposits, by identifying the reflectivity characteristics of different bands, It can effectively identify the changes in the ore body and surrounding rocks, and achieve accurate positioning and prediction.